Good afternoon. Good afternoon. It's a pleasure to be here to share the results of my student that I co-supervised with Professor Beda Barkokebas, which also is here. His name is Cristián, and the work he developed focus on VR-enabled training program for mining construction operators, and then I can move, I guess. Just to talk a little bit about myself, so we know who I am. I'm assistant professor at Pontificia Universidad Católica de Chile. I did my master's and PhD in Canada using virtual reality. Initially, I used virtual reality applications for ergonomics assessment, especially to simulate working conditions that we don't have in a space, for example. And nowadays, I'm expanding my research also to using gamification for education and training of students and also professionals. So first of all, I'll be talking about all these sections about VR. So why it's interesting to use VR for training, right? So we know that we have a lot of benefits. Here I point out some of them. So it improves visualization, so it's way easier for the worker or the student to visualize what they need to do and how they need to do things. Also increases engagement because you are in an immersive learning environment, and it also supports repetitive practice, so you basically can do the same task over and over again, and in a less costly manner than when you have a physical prototype, for example. And it's a risk-free space. So you can been doing, especially if you want to talk about construction, you can be practicing a task that you're not facing the risks of a real world. So if you have all these benefits, why we're doing research is still investigating that? Because basically we have a lot of studies, but we don't have studies encompassing the details of how the training impacts the workers afterwards. And most of the studies, including, I have a study for ergonomic analysis, for example, that I verified the impact before and right after the training, but I couldn't verify the impact 4 months later or 6 months later to see how the workers retain this information that they receive using virtual reality. So, and also VR is important because according to, I think most of you might know this pyramid of learning effectiveness. According to Deus pyramid, when users are engaged with active learning, and especially when they are simulating a task in, for example, virtual reality, studies say that they retain up to 80% of the knowledge that they receive. So it's way higher than when we're comparing to, for example, reading a text. So that's why the objective behind this study is to exactly evaluate if this percentage of this knowledge retention actually happens in the construction. So, just to give a little bit of background, mining construction in Chile is a huge part of our economy, but still we have a lot of deficiencies, especially related to productivity. So the equipments are really good, they are really efficient, but the workers, they struggle sometimes to use these equipments to the higher of the efficiency. And so we have an opportunity to use VR as an innovative approach to improve workers' productivity. So the main objective of the research was to actually implement a VR-based, VR-enabled training program tailored for mining construction operators, with the objective of verifying the impacts of the program, especially short-term impacts and long-term impacts. And to do that, we simulate 2 different types of equipments. The load-haul dumping equipment, which basically handles all the material and transports this material on confined underground spaces. And we also use the jumbo equipment, which is used to drilling tasks, especially for tunnel and structural stability. So the research methodology, the design of the VR training program itself was not developed by the student. So we focus on the implementation and the assessment of the results. So I'll talk a little bit more about the implementation, which kind of workers did we have, and how many workers passed through this training. So for the LHD, which is the load hand dumping equipment, we simulated tasks that they would face in the real world, right? And they were assessed through various exercise, and both theoretical and practical. The same thing happened with the Jumbo simulator. So they also faced theoretical and practical applications of the tasks that they would perform in the site. And we use the Oculus VR technology and some immersive equipment to help with this training. So some of the aspects that we evaluated were, sorry for the typo here, obstacle avoidance, arm movement, mind driving, so how they were performing, moving around the mining, blind spots, so if they could see or not some objectives, so objects, pre-operation check, ignition procedure, and for Jumbo equipment, they also perform the drilling part. And for the LHD, they only perform the transportation part, which is also really important. While they were performing the simulation, by the end, we already have some kind of instantaneous results of how they performed during the simulation of the task. So for the assessment, we got 35 workers divided in between 16 LHD operators and 19 Jumbo operators. And the key performance indicators for them, they were a little bit different because of the characteristics of the machine, the equipment. So for the LHD, we assessed the number of buckets moved per operator and also how many buckets moved per hour. And for the Jumbo, we checked how many meters they drilled per month and also the achieved blasting efficiency. And just to have a global results, so we could verify the productivity before the training and after the training. So before the training, we could see that they were performing around 32 buckets per month, right? And after the training, we could see improvement for 41 buckets per month. So, and that's talking about the same operators in the same construction area. So based on that, we can verify that we had a 30% more or less improvement on the performance. And we also went a little bit deeper to analyze each worker. And for example, for the LHD, we have here the results for the operator number 3, which was one operator that performed before the training in really average. So we used this one to verify how improved his efficiency was. And we could, so basically, I forgot to mention that. So we had 2 training sections. The first one, so basically they got the first interaction with this kind of training, right? And then we verify the performance right after this training. And then after that, they had another training 4 months later. And we also performed the check 4 months after the second training section. Beda, yeah. And then we could verify how the productivity of each worker increased during this time period. So for this worker specifically after the second training section, so when you see here month 3, it's exactly the 3rd time that we check his efficiency. We could see an efficiency that increased around 50% in comparison to the first time that he was assessed. So it was a really interesting result for us. And talking about the other equipment, we also have the overall results. So they used to have around 160 meters drilled in a month and average. And then after the training, they start to perform relatively better and reaching to 205 meters per month. So a 25% increase also in productivity. So in this case, we also went a little bit deeper in each operator. And operator number 10 was an operator that actually performed really lower than average. So we want to make sure that if this operator could also have an increase in the productivity. And so you can see that for this operator in particular, in the second time that we checked his efficiency, he actually went lower, right? But then when we check after, so here after 8 months, in comparison to the beginning, he had an increase also of 16%. So which also are interesting results for us. So in conclusion, there are some interesting results in this study. We also, just in the beginning of this study, so we want to expand the implementation of the training. But we could see that we had some positive impact on the productivity of these operators. And we could also customize the training. That was one of the feedbacks that we received from the workers. That was really interesting that to have some sort of customization for them. And I did not include in the presentation because of the time, but the paper have some information about generation gap. So we also verify if according to the age of the workers, the productivity would have some impact. So if, for example, older workers would have less, increase less their productivity because any barrier with the technology, which was not the case. So in all age groups, we verify an improve in the productivity, but since we didn't have too many workers, we could not have a robust statistical analysis on that. So that's why I did not include in the presentation. But it was interesting to see that VR training did have a potential benefit across all different age groups. And also, it's really important to have a really strategic implementation in the company. So one of the things that VR is costly sometimes to improve, to implement, but you need to have the goal really well defined before you do it. So we can actually have a cost-effective implementation. And the directions of future research would be exactly to have more case studies and to test that with more workers so we can verify if the same results would be replicated to a broader range of workers. Yeah, that's my presentation for today. Thank you very much, and I'm here to answer any questions.